So for part A of this one, and first off, we're given the graph of function f, and we're given that g of x is the integral from 2 to x of f. And first thing we want to know is if g has a minimum or maximum or neither at x equals 10. So if I could get a pen that would work here, we could start doing this. There we go. All right. So to figure out if g has a min or a max or neither, we need to take the derivative of g prime is equal to f of x. And so we're looking for when does f of x equal, or sorry, we're looking at 10, what does f of x equal? And at 10, f of x is equal to 0, which means that we could have a max or a min, but because the derivative, f, is negative to the left of 10 and then still negative to the right of 10, that means that we have neither at x equals 10. And your explanation would be no sign change of g prime. Good or no? Hopefully good. All right. Part B, does the graph of g have a point of inflection at x equals 4? Remember, graph of g, so g double prime should be f prime. So we're interested in, does the derivative of f change signs at 4? Well, yeah, the derivative of f is positive slope here. And then the derivative of f is negative. We have a negative slope to the right of 4. And so the answer should be yes, f prime or g double prime goes from positive to negative. Good or no? Any questions, any issues there on A or B? Both of those are just worth 1 point. Just to make sure you all can still hear me, right? Am I just like frozen again? Okay, cool. Just want to make sure. I'll probably have to do that multiple times today for my own sanity here. All right, part C. We want to find the absolute minimum and the absolute maximum value of g on the interval from -4 to 12. And then we're going to justify our answers. So if we're looking for the absolute min and the absolute max on a closed interval, that means that we definitely have to test -4 and 12. And from -4 to 12, we also have to look for all of the critical values of g. So when does f prime equal 0 on that interval? And so, sorry, not when does f prime, but when does g prime, which is f. So that'd be here at -2, then be here at 2, here at 6, and here at 10. But we know for sure that there isn't a max or a min at 10 because there's no sign change, and the same thing at 2 because there's no sign change of f, but there is a sign change of f at -2 and a sign change of f at 6. So we're going to need to make a chart here. Let's see, we're going to have to put negative. So here's our x value. Here's our value of g of x. This is going to be -4. We're going to have a -2. We're going to have a 6, and we're going to have a 12 on this chart that we're going to make. And so if we look for the integral from 2 to -4 of f of x, well, that's the same as the opposite of the integral from -4 to 2 of f. So we need to look for the integral from -4 to 2. So first off, this piece is just a triangle, height of 4, base of 2. So 1/2 of 4 times 2. Since it's below the x-axis, it'll get a negative. And then the second part of it is this triangle from -2 to 2, which has a base of 4 and a height of 4. So that's 1/2 of 4 times 4. And all of this needs to be negative since we flipped it to make it the opposite of the integral from -4 to 2. So here we've got 8, and then here we've got 4. So we've got 8 minus 4 is 4, and then the opposite of that is -4. Everybody good with finding the value at -4? All right, find the value at -2. We're going to do the opposite of the integral from -2 to 2 of f. So now we've got the opposite of, and then from -2 to 2, it's just this 1/2 4 times 4, which should give us -8. Any issues with the value at -2? All right, and then at 6, we're going to go from 2 to 6. That's this same triangle here, 1/2 of 4 times 4. So that one's just going to be 8. And then if we go all the way to +12, we're going to have this positive piece, this negative piece, which is the same exact size. So those will cancel out. And then we have this -4 from this triangle right here. So that value is -4. And so we would see that our absolute min is -8 at x equals -2. And our absolute max is 8 at x equals 6. Good or no? And that was worth 4 total points there. So 1 point for looking at x equals -2 and x equals 6, 1 point for looking at the endpoints, and 2 points for the right answers. All right, and then the last part is, when is g of x less than 0? So in order to figure out when g of x is less than 0, all we've got to do is plug in our different values here, coming across from 2 to wherever we're looking at. So we know that if we're going from 2 to -4, hold on 1 second. Okay, sorry about that. So we know that the value at -4 was already -4. So we knew we were negative there. And we were negative all the way up to -2, right, at -8 there. And then it took us 8 more units to get back to 2. At 2 is where it becomes 0, right, which we should know because the integral from 2 to 2 should be 0. So we should be negative from -4 to 2. And at 2, it's 0. So we'll give ourselves an open bracket there. And then it should be an open parenthesis. Then it should be positive from 2 to 6 for sure. And it should still be positive until we get to 10, because that's when these cancel out. So then it should be negative again from 10 to 12. And that's worth 2 points. And I'm not sure why, but on their answer key, they wrote these as brackets, but I think those should be open parentheses there for those. Since at 2 and at 10, it's 0. Oh, never mind. If I read the problem where it says less than or equal to, then you should definitely put a bracket there. My fault. I just thought it said less than. Any questions on that one? Everybody okay with that? So I got from 10 to 12 because, well, first off, I knew that at 2 it was 0, right? From 2 to 2, it's 0. So then I knew I got 8 units of positive area, so it was always positive from 2 to 6. And then I canceled out those 8 units here. Those were -8. So by the time I got to 10, I was at 0 again. And then this next section from 10 to 12 is below the x-axis. And so therefore, that's adding more negative to it. Does that make sense? Did you hear that? My laptop said my connection was unstable as I started talking. So were you able to hear me? You're good? Okay. Cool. All right, you guys have done this one already too, I believe. Ones I asked you guys to do. Okay. Cool. So we've got a graph of f prime, which is the derivative of the twice differentiable function f. Gives us places where this has horizontal tangents, so -1, 1, and 3. And it gives us the areas of the regions bounded by the x-axis and f prime on those intervals. So from -2 to 1, this is 9, and from 1 to 4, that's not 9, that's 12. So this section is 9, this section is 12. We want to find all x coordinates at which f has a relative max. So if f has a relative max, that means that f prime needs to do what? Needs to go from positive to negative. We're going to have a relative max. So that happens here at -2. We go from positive to negative there. So that's our only place. That's the only time where it goes from positive to negative. Everybody good with that there? At -3, it's not a relative max. Just, we're thinking about the endpoints, our function should be increasing from -3 to -2 still, even if it's not increasing very quickly. And here it should be decreasing, so that's a relative min. So if it asks for relative mins, you'd have to include the endpoints of that. But it asks about maxes, and both of those are not maxes. Okay, and that was worth 2 points. Okay, part B, we want to know on what open intervals in -3 to 4 is f concave down and decreasing. So if f is concave down, we need f prime, sorry, if f is concave down, we need f double prime to be less than 0. And if f is decreasing, we need f prime to be less than 0. So we're looking for our graph to be below the x-axis and for the slopes of our graph to be negative. So when are we below the x-axis? Well, from -2 to 4 effectively, except for 1 there. And the slopes are also negative of that anytime this function is decreasing. So we're looking for when is f below the x-axis and when is f decreasing. So that'd be -2 to -1. And also from 1 to 3. And that's worth 2 points. Everybody good with that? Any questions on that one? Yes, so always use parentheses when you're talking about concavity. 100% of the time. All right, part C, we want to find all of the x coordinates of points of inflection for f. So if f has a point of inflection, that means that f double prime needs to change signs, which means that the f prime needs to go from either increasing to decreasing or decreasing to increasing, right? So when does f prime change from increasing to decreasing, since that means the derivative is going from positive to negative or negative to positive. So that'd be here at -1, f prime goes from decreasing to increasing. And then again at 1, where f prime goes from increasing back to decreasing. And then down here at 3, where it goes from decreasing back to increasing. So those are all possibilities. And then we need to think about what's happening at each of these. Let's see here. -1. Yep, those should all be good, right? They're all going decreasing, increasing, increasing, decreasing, decreasing, and increasing. So good or no? Oh, and this is worth 2 points. Sorry, somebody just asked about that. Cool. And then part D, given that f of 1 is 3, we want to write an expression for f of x involving an integral. And then we want to find f of 4 and f of -2. So f of x ought to just be, and this is just our fundamental theorem of calculus stuff here, it should just be the initial condition plus the integral from 1 to x of f prime of t dt. So that's 1 point for that. And then to find f of 4, we just need to integrate from 1 to 4. Well, this area is 12. So we should get 3 plus, and then if we're going from 1 to 4, this is 12 here, but if it's below the x-axis, it should be a -12. And so that should give us -9. And f of -2 ought to be 3 plus the integral from 1 to -2 of f prime. And that should be 3 minus the integral from -2 to 1 of f prime. And let's see here, from -2 to 1, that integral is 9 units. So that's a 3 minus, and then since it's below -9, which gives us 12. And let's see here. Yeah, that's 3 points total for that. 1 point for using the initial condition, 1 point for that, and then 1 point for the 2 answers. Any other questions on that one? Everybody okay with that one? All right, and I believe this is the last one that I asked you guys to do in advance. Is that right? So first off, this is the graph of f, and we have g, which is the integral from -3 to x of f, and all of these are line segments. So we want to find g of 3. G of 3 ought to just be the integral from -3 to 3 of f. And if we're going to do the integral from -3 to 3, first part of that is from -3 to 2. That's a triangle, so that should be 1/2 of the base, which is 5 units, times the height, which is 4 units. And then we need to subtract from that this little piece below here from 2 to 3. And from 2 to 3, that's a base of 1 and a height of 2, since this is linear, and we're going from 2, 0 to 4, -4. So 1/2 of 2 times 1, which would be 10 minus 1, which would be 9. And that was worth 1 point. Any questions there on part A? All right, part B, similar to the last question, we want to know on what open intervals is the graph increasing in concave down, graph of G. So G will be increasing if f prime is positive, and concave down if f double prime is negative. So f prime is positive, or sorry, not f prime, g prime, and g double prime, and g prime, g prime, which is f, and g double prime, which is f prime. So f prime is positive up here, and then f is positive up here, and f prime is positive whenever these slopes are positive. So that's just this section from -3 to 0. Oh, f prime is negative. I should probably read this thing better. Sorry, somebody pointed it out to me. I said f prime needs to be negative. That's these intervals. -5 to -3, and 0 to 2. I was looking for when it was positive for some reason. Everybody get there with part B? That's worth 2 points. All right, part C, we got a new function h that is defined by g of x over 5x. We want to find h prime of 3. So first off, let's write an expression for h prime. We have to use the quotient rule for that. So that'll be 5x times the derivative of g, so 5x g prime minus derivative of the denominator 5 g of x over 5x squared. And we're looking for h prime at 3. So that ought to be 15 times g prime of 3 minus 5 times g of 3 over 15 squared. And let's see. G prime, which is f, at 3, looks like that's -2. So this will be 15 times -2, which will be -30. And then minus 5 times g of 3, which was 9, so minus 45. So we got -75 over 225, which I believe reduces to -1/3. And that was 3 points. 2 points if you got the derivative, 1 if you found the value at 3. Good or no? Any questions on that? All right, and part D. We got p of x, which is f of x squared minus x. We want to find the slope of the line tangent to p when x is -1. So that means we need to find p prime, which ought to be, this is just the chain rule, f prime of x squared minus x times the derivative of x squared minus x, which is 2x minus 1. And if we're looking for that when x is -1, that ought to be f prime of -1 squared is 1, minus -1 is 2, so f prime of 2, and then -2 minus 1. So f prime of 2 times -3. And f prime, the slope of this at 2, is -2. So we get -2 times -3, which should be 6. And that was worth 3 points also. 1 point, 2 points for getting the right derivative and 1 point for evaluating it at -1. Any questions or issues there? Okay. How do we feel about these area problems? Or these graph with area underneath and all this other stuff? We're feeling okay about them?